Morning, students. I'm going to start the class and you listen very carefully. And now, first of all, I'm going to revise the little bit that I explained in the last class. Now we are going to discuss about the nuclear fission. Okay, today topics are the nuclear fission, next to fusion. Okay, today topics are the nuclear fission, next to fusion, next, nuclear reactor, source of stellar energy. These topics we will discuss. Okay, listen carefully. Now the time I will continue for the more than 1 hour. Okay, and students, is my voice clear or not? The topic is the nuclear fission. What is nuclear fission? Nuclear fission means in the last class only we discussed. Can anyone write in the chat box what is nuclear fission? What is nuclear fission? Nuclear fission is the phenomenon of splitting of heavier nuclei into two or more lighter nuclei. Right? The phenomenon of splitting of heavier nuclei into two or more lighter nuclei with comparable masses that we discussed previously. Right? Now I am going to continue it. Right. The definition of the nuclear fission is the phenomenon of splitting of splitting of heavier nuclei into two or more lighter nuclei with comparable masses. This is called as nuclear fission. Previously we discussed. In the why the heavier nuclei will split into lighter nuclei? Because actually the heavier nuclei having less binding energy, they are not having the less stability. That's why to attain the stability, the heavier nuclei will be split into two or more lighter nuclei with comparable masses. Okay, now one reaction in the last class I said for the nuclear fission, right? That is what, for example, the example is when one neutron is bombarded on one heavy nuclei, that is uranium. That is a uranium mass number is 235 and atomic number is 92. And now when this will be combined, you will get the barium and the krypton. Okay, in the barium, atomic number is 56 and the mass number is 144, and the krypton has atomic number 36 and the mass number is 89, and along with that three neutrons releases, along with that some energy releases. That energy release rate here is 200 mega electron volts. That means if one uranium undergoes fission splitting, then in that two particles will releases barium and krypton. Along with that, three neutrons releases. What happening it here? This heavier nuclei split into two comparable lighter nuclei, barium and krypton. This phenomena is called as nuclear fission. Okay, in some of in NCERT book, like this equation is there. In sometimes there is a chance to form the barium other isotope, right? And that means the isotope means what? It has a isotope means what is isotopes? Can anyone write Sushmita or Sunita Gagarai? What is isotope? Write in the chat box. What is an isotope? Isotope means it has the same number of atomic number but different mass number. In some of the reference in NCERT book, this is the equation. But if you refer some of the reference books, in sometimes it may be have here it will be reduced by 3, 141 barium isotope formed. That means mass number is 141 and the krypton mass number is 92. Then there is no problem. Okay, the balance it will be balanced. 144 plus 89 plus 3. It will give 235 plus 1, 236. Here we are getting the mass numbers. If you will add 1 plus 235, 236. If you will add the 144 plus 89 plus 3, that is also you will get the 236. Here 92 plus 0, 92 you will get. Here 56 plus 36 also 92 you will get. This is about nuclear fission. Nuclear fission means the splitting of heavier nuclei into lighter nuclei. What is the reason for the splitting? To attain the stability, right? Why the nuclei will be heavier nuclei will be split into two lighter nuclei, right? To attain the stability, to increase the its binding energy, average binding energy. Okay, the next topic we discussed is chain reaction. What is chain reaction? What is chain reaction? Chain reaction means actually this uranium is used in the this uranium used in uranium is an explosive material. It can be used to make the some bombs we can make by using this uranium sample. Okay, then let us go for the chain reaction. What is a chain reaction? Chain reaction means, for example, we have a uranium sample. If you have the uranium sample, for example, uranium sample this much, for example, in that 1 lakh uranium atoms are there. 1 lakh uranium atoms are there. In that, one neutron is allowed to bombard on one uranium. Okay, that uranium is 92U235. Okay, and when one neutron is allowed to bombard on the uranium, this equation will takes place. When this equation takes place, what happens? Uranium will be split into barium and krypton, right? Along with that, what happens? Three neutrons releases. Okay, these are the three neutrons, right? And now these three neutrons, this sample has so many atoms, then these released neutrons on an average sometimes two neutrons releases, sometimes three neutrons releases. These on an average we will get the 2.5 neutrons releases in each fission. Fission means what? Splitting. Okay, right. Is it clear, students? Oh, right, voice and picture everything is clear now. Good. Now request your friends to come to the join in the class, because very few members, only 7 members are watching. Okay, and these three neutrons allowed to bombard on the three more uranium atoms. This is 92U235, and this is one more uranium. Okay, and this is one more uranium. Like this, what happens? In this also again the this will be split into barium and krypton. This will also split into barium and krypton. Along with that, what happens? Energy releases in everywhere. Okay, three neutrons releases like this. Three neutrons releases. In the each fission, three neutrons releases. According to this equation, the neutron bombard on one uranium, then three neutrons releases. That means this chain reaction will be continuously takes place, right? Because of release of the neutrons. One fission means 1 fission means 3 power 0 we will take, that is a 1 fission. Okay, and here 3 fissions are occurred, 3 uraniums undergoes splitting, 3 per 1. Next undergoes the 9 fission undergoes the, this one how many, 1 9 1 2 3 4 5 6 7 8 9, 3 power 2, right, 3 power 2, 9 neutrons undergoes fission. Firstly only one, sorry, firstly only one uranium undergoes fission, next 3 uraniums, next 9 uraniums. Like this in geometrical progression, what happens, the more number of uranium undergoes splitting, and within short period the large amount of energy releases, it causes the explosion. That's why they are used in to make the bombs. Okay, right. Now let us go for the actual which type of bomb they will make. They will make the nuclear bomb based on this. Okay, right. Is it clear, students? Any problem? Priyamato. Right, okay. Now let us continue. And this is about the nuclear fission and chain reaction. And then this is the, for example, in the, whether this chain reaction will be continue or not continue. Okay, for example, here the 3 neutrons are released. In this sample has many uranium atoms. If one time you initiate that uranium undergoes splitting, at the moment 3 neutrons releases, these 3 neutrons bombard the 3 more uranium atoms, and like this what happening it here, this reaction will be continuously takes place. That's why we call it as chain reaction. In the chain reaction large amount of energy releases, that causes the explosion. Okay, and that's why it is used, they are used in the bombs, nuclear bomb, right. In the nuclear bomb what happen, nuclear fission takes place. Okay, right. And now in the nuclear fission what happening, energy releasing in the each fission means what, splitting. Okay, right. And for example, if you want to stop the fission, if you, this will become uncontrolled. You see, only first one uranium undergoes fission, next 3 uraniums undergoes fission, next how many uraniums undergoes fission, 1 2 3 4 5 6 7 8 9, 9 uraniums undergoes fission. Like this what happening, the number of neutrons, the fission rate will be increasing. That's why it will become uncontrolled chain reaction. It will become uncontrolled chain reaction, and large, within fraction of seconds large amount of energy releases, it causes the explosion. And now if you want to stop this, what you have to do, for example you want to stop the uh, chain reaction, further what you have to do, for example here 9 neutrons are released, 3 3 3 9 neutrons released. If we not, we something we have to keep, and we have to observe these neutrons. For example I observe total 9 neutrons, here the 9 neutrons are released, 9 I observed, 9 I observed by using some other materials, absorbing materials. Then at the moment what happens, these released neutrons are completely absorbed means, then what happens, there is no further neutron, okay, to initiate the fission of uranium. Is it right? Then at that moment whether the chain reaction stops or not, can you tell whether the chain reaction stops or not? Because we are absorbing all the released neutrons, then what happens, then fission will be stops, because fission, for the fission, for the splitting of uranium, neutron is required. Whatever the neutrons which are released in this, that we are absorbing means, then there is no further fission, the chain reaction will be stops. When the chain reaction is stopped, then we are able to control it, right. Uncontrolled means chain reaction continuously increases. That will be explained based on, if you want to run the chain reaction steadily. For example here 3 neutrons released, then, and I observed the 6 neutron set here by using the control rods or something, right. At the moment what happens, only 3 will be remains in this, 6 absorbed means 3 will be remains, this 3 will be fall on the 3 more uranium atoms. Like this here 3 neutrons, here also 3 neutrons will be causes the fission of the next uranium atoms. That means reaction will be goes steadily. Then that is a steady chain reaction. To know that one, we require to define one, that is one term, that is called as neutron multiplication factor. Neutron multiplication factor. Yes, you know this one already. Neutron multiplication factor. What is neutron multiplication factor? It is the ratio of it is the ratio between number of neutrons in present generation to the ratio between the ratio between number of neutrons number of neutrons number of neutrons in present generation to the number of neutrons in previous generation. Number of neutrons in previous generation. Greater than 1. If k greater than 1. Right? Not appearing clearly, students? Is it appearing? If k greater than 1, if k actually network problem is running, and in sometimes in the middle the network is not catching, that's why I think you are getting some breaks. If k greater than 1, number of neutrons in present generation greater than the number of neutrons in the previous generation. What is the present generation? You see here, we will take this as the present generation and this is the previous generation. In the present generation, how many neutrons released here? Okay, how many neutrons released? 9 neutrons released. 1, 2, 3, 4, 5, 6, 7, 8, 9. In the previous generation, how many neutrons released? 3 neutrons released. That means now K you can find out. Number of neutrons in the present generation is 9. Its previous generation is 3. Right? Total we got 3. This is greater than 1. If K greater than 1, that means number of neutrons in the present generation is greater than the number of neutrons, okay, number of neutrons in previous generation. Then the rate of chain reaction will be increases, number of rate of fission will be increases, number of uranium undergoes fission will be increases, okay, then the rate of chain reaction also increases. Is it right? Yes or no? Is it clear, students? Now the rate of, okay, fission rate will be increases, right? And number of neutrons in the present generation increases means rate of fission and rate of chain reaction, okay, rate of fission will be increases. Rate of fission means number of fissions per second, okay, rate of fission increases. Then this state, in this state what happening it here, number of neutrons in the present generation is greater than the number of neutrons in the previous generation. This is called as supercritical state. What it is called? Supercritical state. Okay, in this what happened, it will become uncontrolled, right? Why it is uncontrolled? Number of neutrons in the present generation is more than the previous generation, means the reaction will become uncontrolled. Okay, uncontrolled reaction, chain reaction become chain reaction becomes uncontrolled, why uncontrolled? Okay, why uncontrolled? Numerator greater than denominator means we will get k greater than 1, right? Now uncontrolled. Now let us go for the case 2. The case 2 is that if k is equal to 1 or if k less than 1, then what happens? If k is equal to 1, first we will discuss. If k is equal to 1, what happens? Okay, you see here number of neutrons in the present generation, previous generation are equal. You see here number of neutrons in the present generation is 9, previous generation is 3. How they will be equal? How they will be equal means here the released neutrons. In this there are 9 neutrons released. In that 6 are absorbed by using some material. At that moment only 3 will be remains. That means number of neutrons in the present generation 3, previous also 3. How we make present generation 3? By absorbing the other neutrons. In the present generation 3, previous generation 3 means now the reaction will be runs steadily, right? Rate of fission. Rate of fission means number of splittings, number of neutrons. Rate of fission becomes constant. Okay, rate of fission will be constant. If rate of fission is constant, then we say that it is a steady rate. Okay, steady chain reaction will be occurs at here. Okay, and chain reaction occurs at the steady rate. Okay, rate of fission is constant, chain reaction becomes steady at here. Chain reaction is chain reaction occurs steadily. Rate of fission not increases, not decreases, steadily occurs. Then this is called as supercritical state. Supercritical state. No, 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 it is not supercritical state. Previous one is a supercritical state. Now it is called as a subcritical state. What we can call it as? It is called as a critical state. Okay, it is called as critical state. It is called as critical state. Is it clear, students? You should remember. Okay, next one is the k greater than 1. What happens if k greater than 1? K greater than 1 completed. Okay, k is equal to 1 completed. If k less than 1, k less than 1 means what? Numerator should be less than the denominator. Numerator should be less than denominator. When numerator less than denominator, what happens? When numerator less than denominator, number of neutrons in the present generation less than the previous generation. That means you see this diagram. In this diagram, okay, Aditi. And you see in this number of neutrons in the present generation is 9, number of neutrons in the previous generation is 3. Then in the present generation, what I did, I observed the 1 2 3 4 5 6 7 8 neutrons I observed. Out of 9, if you observe the 8, only 1 will be remains. Number of neutrons in the present generation will be 1. Out of 8, 9 released it here, but 9, in that 9 I observed the 8. Okay, 1 will be remains. Number of neutrons in the present generation is 1. Number of neutrons in the previous generation is 3. Then number of neutrons in the present generation is 1. Number of neutrons in the previous generation is 3. 1 by 3. That means it is a k is less than 1. K less than 1. If k less than 1, then that is called as subcritical state. Subcritical state. Okay, you should remember the words. What is supercritical state and what is subcritical state, like that. Next, let us go for the case 3. Okay, the case 3 is very simple. Oh, that is the k value. It is based on the if k less than 1. K less than 1 means number of neutrons in the present generation should be less than the previous generation. Is it right? Number of neutrons in the present generation should be less than the previous generation. That means with the number of neutrons should be decreases successively. Is it right? That means the rate of fission also decreases. Rate of fission is nothing but how many neutrons are there, that many fissions will be takes place. Rate of fission decreases. Rate of fission means what? Number of fissions per second. Number of fissions means what? Number of splittings per second. Number of splittings of uranium based on the number of neutrons. If k less than 1, rate of fission decreases. Rate of fission decreases means that is called as what is the name of this state? This state is called as a subcritical state. Remember it. Subcritical state. Right? Okay. We discussed about the supercritical state, critical state, and subcritical state. Generally, we will use at the steady rate. At the steady rate example, I will give in the nuclear reactor. Steady in the steady rate, we chain reaction will be occurs, and the released energy, the released nuclear energy, the nuclear fission energy releases that is used to uh, convert into electrical energy. Let us discuss about the one most important application, that is the nuclear reactor. Nuclear reactor. Okay, right. What is a nuclear reactor and how it will be works? You take the screenshot and I will continue. Continuing the class. Now the reconnection is successful. I changed the settings because of now it is clear now. Yes. Now going to start the class. Nuclear reactor. What is a nuclear reactor and how it will be works? That I am going to explain. Nuclear reactor means it's a device. It is based on the chain reaction. It is based on the chain reaction and it is based on the nuclear fission. Then how it will works? We will discuss clearly and you listen very carefully. Right? And now it is okay, students. Right. Let us start. Is it okay? Write in the chat box. Right. What is a nuclear reactor and how it will be works? Okay, Tinkle, thank you, and I am going to continue. Right. Nuclear reactor is a device. Nuclear reactor is a device. Nuclear reactor is a device in which nuclear fission can be carried out through the sustained and controlled chain reaction. That is called as a nuclear reactor. Nuclear reactor is a device. It will works based on the chain reaction. Okay, I will write the definition of this one. That is a device in which nuclear fission nuclear fission can be carried can be carried can be carried out through sustained and controlled chain reaction is called as nuclear reactor. What is a nuclear reactor? What is the definition of the nuclear reactor? Nuclear reactor means it is a device, right? Nuclear reactor is a device in which nuclear fission can be carried out. Nuclear fission can be done. Nuclear fission means what? Splitting of the heavier nucleus into lighter nuclei. A device in which the nuclear fission can be carried out through the sustained and controlled chain reaction. That is called as nuclear reactor. Controlled chain reaction takes place and sustain means it will continue. And in that, let us discuss about the construction. For that, I will draw the diagram. And that is nuclear. Before that, I will give the parts of the nuclear reactor. Nuclear reactor consists. Nuclear reactor consists mainly five parts. Okay, and that are the first one is the nuclear fuel. Nuclear fuel, and the second one is the moderators. Moderators. Third one is the control rods. Control rods. And the fourth one is the coolant. And the next one is the protective protective shielding, protective shielding. It is also called as reflector. Is also called as reflector. These are the various types of various parts of the nuclear reactor. We will draw the diagram of the nuclear reactor and I will explain how it will be works. Nuclear reactor is what? Actually, it is a device in that nuclear fission takes place, but controlled chain reaction. If it is uncontrolled, then what happens? If it is uncontrolled, the continuously uranium undergoes fission. Due to that, what happens? The large amount of energy releases that causes the explosion. Then we should not explode. We have to convert the nuclear energy into electrical energy. That's why it should occur chain. It should occur steadily and it should be controlled whenever required. Right? That's why it is a device that in that nuclear fission takes place at the controlled chain reaction. Okay, that is a nuclear reactor. Now let us go for the its diagram and you listen very carefully. And this is a core. We will discuss this one as core. Okay, this is the core. In the core, what will be there? It is the core. In the core, fissionable material will be there. Fuel will be there. Okay, it consists fuel. Right? The core is surrounded by a layer that is called as the reflector. We said the fifth part, that is the reflector. Okay, and we keep some control rods at here. That is the third part. I will explain the use of each and every one. Okay, and don't be in tension. It will be clear for you. Don't worry. Whenever the required, these control rods can be inserted into that, and whenever we want to remove this control rods, we can remove. These are movable. Okay, these are the control rods. And the next one is there is a one pipe set will be there. This side steam will goes and this side water from condenser. I will explain after drawing the diagram. Okay, don't worry. And you listen carefully. This is the coolant and right. This is about the nuclear reactor. This is the diagram of the nuclear reactor. Now let us start its working and its construction, its parts I will explain one by one, and how it will works also I will explain. Okay, you listen very carefully. Right. We are discussing the nuclear reactor. What are the various parts in the nuclear reactor and what principle it will works? Nuclear reactor works based on the nuclear fission. 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 Fission means what? Splitting. Splitting of the heavier nuclei into two or more lighter nuclei. That is called as nuclear reactor. It is a device. It is It works based on the nuclear fission. Let us discuss about the each part and later working we will discuss. What are the various parts in it? First of all, nuclear fuel. Nuclear fuel. What is a nuclear fuel? Nuclear fuel means actually to run anything. For example, you want to run your bike. For that, what you require? If you want to run the bike, fuel is required. Which fuel you will use in the bike? Write in the chat box, students. Which fuel you will use in the bike? Which fuel you will use in the bike to run it? Is it clear, students? Komal is telling that फिर से Aditi Twinkle. Is it clear now? Is it appearing or not appearing? In my mobile, it is appearing. Okay. Now let us see here. Nuclear fuel means which type of material we have to use in the nuclear reactor as fuel. In the bike, we will use we will use what fuel we have to use in the bike. In the bike, you will use right in the chat box. What you will use in the bike? No one writing. Yes, the twinkle is telling the petrol, right? That is the nuclear fuel. Similarly, here to run the nuclear reactor, we have to use some fuel, and that is the uranium, right? Uranium undergoes splitting, and then after that, energy releases. Uranium undergoes fission, and then after that, it will be releases. When the uranium undergoes fission, the energy releases, right? And let us see what we have to use the nuclear fuel, the fissionable material. Fissionable material we have to use. Fissionable means it is able to split. Fissionable material. Fissionable material can be used as fissionable material can be used as nuclear fuel that is kept in the core. And what fissionable material you will use? The example is uranium 235 can be used as nuclear fuel. Okay, and then next let us go for the second point, that is the second type is the moderators. What is moderators? Okay, moderators. One thing you remember that actually in the chain reaction what happening, when the neutron bombard on the uranium, okay, and then uranium undergoes fission, that means only slow neutrons, only slow neutrons initiate the initiate the fission of uranium. Okay, fast moving neutrons does not causes the fission. Only slow neutrons can cause the fission. That means what we have to do, if the released neutrons are fast moving neutrons, they cannot cause the fission. Then to occur the fission, what we have to do, the release in the when the uranium undergoes splitting, fission takes place. In when the uranium undergoes fission, the three neutrons releases. That three neutrons, if they are fast neutrons, they cannot cause the three fission of three more uranium atoms. For that, what we have to do it here, we have to slow down the fast moving neutrons. then further we have to use the moderators, right? And the slow neutrons are called as thermal neutrons. Slow neutrons, slow neutrons means its speed is less. Its speed is less. This slow neutrons are called as thermal neutrons. What they are called? Are called as thermal neutrons. Then actually when uranium undergoes a fission, for example, one neutron is allowed to bombard on the uranium. This will be split into barium and krypton. Three more neutrons will be released. But these neutrons' speed is more. Then, but to cause the further fission, to initiate the further fission, what we require? Slow neutrons are required. Then how we can slow down that neutrons? By passing through the moderators. Right? We have to decrease the speed of the released neutrons. Okay, for that we will use the moderators. Moderators are used to slow down the fast moving neutrons. Why we have to slow down the fast moving neutrons? Because only slow neutrons can cause the fission. That's why we have to slow down the fast moving neutrons. Okay, I will give the moderators actual point, that is the materials that are used, okay, the materials that are used to, okay, that are used to slow down the slow down the fast moving neutrons, fast moving neutrons produced in the fission. The materials that are used to slow down the fast moving neutrons are called as moderators. Which are used as the moderators? Heavy water can be used as moderator, and the graphite can be used as moderators. Okay, right. Fast moving neutrons. What is the use of the moderators? Moderators are used to slow down the fast moving neutrons. The metals that are used to slow down fast moving neutrons, okay, released in nuclear fission, right now, right. Then what are materials? Which materials you have to use? Example is heavy water and graphite can be used as moderators. Heavy water and graphite can be used as moderators. And the next one is third one. Third one is what? What is the name of the third one? What I give? Control rods. What are the use of the control rods? Control rods. Control rods means, okay, these are in the name only it is there. Okay, in the name only they can control the chain reaction. Okay, how they will control the chain reaction? For example, if you want to stop the chain reaction, how you will stop the chain reaction? Can you write in the chat box? The material that can be used, that can be used, the material that can be used to absorb the neutrons are called as control rods. Control rods are used to absorb the neutrons. Okay, if we absorb the neutrons, what happens? The chain reaction will be stops. But to continue the chain reaction, what we require? We require the neutrons. If the released neutrons are absorbed, then what happens? The chain reaction will be stops. That means the material that can be used to absorb the neutrons are called as control rods, which can be used as control rods. Right? Boron and cadmium can be used as control rods. What is the use of the control rods? These are used to the metals that can be used to absorb the neutrons. By that, what they will do? Okay, control rods can control the chain reaction. Control rods used to control chain reaction. Control chain reaction. Control means if you want to stop the chain reaction, then we can use these control rods. You insert the control rods, then at the moment all the released neutrons can be absorbed by the control rods. When the neutrons are absorbed, the chain reaction will be stopped. The control rods are used to control the chain reaction. Control the chain reaction. How they will control the chain reaction? By absorbing the neutrons. How they will control the chain reaction? By absorbing the neutrons. Okay, right. Is it clear, students? Next part we will discuss. What is the next part? The next part is fourth part is the coolant. What is the use of the coolant? Coolant means, okay, actually in the fission what happened? Large amount of energy releases. Okay, large amount of heat developed in the nuclear reactor due to the chain reaction. That heat can be removed by using a suitable coolant. Okay, large amount of large amount of large amount of heat developed or the produced heat developed in the reactor due to chain reaction large amount of heat energy releases, right? What that heat will do, that we have to absorb that heat energy, then the heat is removed. We have to remove that heat. Further we have to use the water, right? The water can gain the heat energy, then that will be converted into steam. The heat is removed by suitable coolant. That coolant can use it to absorb the heat produced in nuclear reactor. The heat is removed by suitable coolant. Okay, what the coolant will do? The coolant absorbs the heat. Okay, and which material we will use as coolant? Very simple. Water at a high pressure. And one more is molten sodium can be used as coolant. Then what is the next part, last part? Protective shielding. Once again I will explain all the parts in one time only. Protective shielding, it is always reflector, right? What is reflector and what is the protective shielding? This is used to protect the, actually in the nuclear reactor what happening, when the uranium undergoes fission, for example when neutron is bombarded on the uranium, what happening at here, this uranium undergoes splitting into barium and krypton. Along with that, the neutrons releases some energy releases. In this barium krypton also undergoes the fission, and they are the radioactive material. Means they will emit the radiations like alpha, beta, gamma. These radiations are very harmful for the human being and surrounding also. Then that's why we in the nuclear reactor, the nuclear reaction takes place. In the nuclear reaction, what happens? The harmful radiations will be emits. If that harmful radiations will be enters into the atmosphere, and it can damage the surrounding of nuclear reactor, and it can damage the people and the animals and the plants which are around the nuclear reactor. That's why to protect the surrounding of nuclear reactor we use one reflector, and that is the what this reflector will do. This reflector can reflect the radiations which are emitted in the nuclear reaction. Okay, that can reflect back and not allow the radiation to enter into the atmosphere. Due to that, what happens, the atmosphere will be protected. For that 10-meter thickness concrete wall, very large thickness, that thickness wall can be produced. Okay, right. to protect the to protect atmosphere, to protect surrounding or the atmosphere. Okay, to protect atmosphere or the surrounding, what we have to do, right? To protect the atmosphere or the surrounding from harmful reaction, harmful from harmful radiation. To protect atmosphere from harmful radiations released in nuclear reactor. In a nuclear reactor, nuclear fission takes place. In that, harmful radiation will be released. To protect the atmosphere from harmful radiation, we use the protective shielding, and this is the last part of the nuclear reactor. To protect atmosphere from harmful radiation released in nuclear reactor, released in nuclear reactor, we use we use 10-meter shielding. Shielding means forming a layer. We use protective shielding. Okay, protective shielding. How we will make the protective shielding? By using what we have to make the protective shielding? The protective shielding can be, okay, nuclear radiations. So just like what type of radiations will be releases? Nuclear radiation like alpha, beta, and gamma. Okay, rays emitted during nuclear fission. During nuclear fission. To protect from leakage of these radiations, or the leaking of these radiations, to protect from leakage of radiation, what we have to do? Suitable shielding. Suitable shielding. Shielding means just forming a layer. Suitable shielding such as steel, lead, concrete, are provided around the reactor. Okay, this is called as the protective shielding. What we have to do it here, to protect the surrounding from alpha, beta, gamma radiation, what we have to do, right? We have to shield them. Okay, we have to use the suitable shielding. Suitable shielding means a layer. That layer is made up of steel, lead, concrete. Okay, right. This is about the different parts. And now working we will discuss. Okay, working, how it will works, how it will works. Working, very simple working it is. I will explain by using one's diagram. Okay, we will go for the diagram. Okay, look at here. I will explain the working with the help of the diagram. Right, I think now the diagram is appearing clearly. You see here, this is the core. In the core, uranium fuels are there. In the core, uranium fuel is there. This uranium, okay, one slow neutron is allowed to bombard on the uranium. This uranium, this uranium undergoes fission. Okay, and three fast neutrons are released. That fast neutrons are released by passing through the moderators that also present inside the core. Actually, inside this is the core. Inside the core, fuel is there and moderator is there. But when neutron from outside, we will send one neutron to start the reaction, and then that neutron bombard on the uranium undergoes fission, and then three neutrons releases. That three neutrons are passes through the moderator, that is such as heavy water or heavy water or the graphite. And when the that is passes, what happens? That fast moving neutrons will be slowed down. Okay, then the slow neutrons causes the further fission, and after that, if you want to control the chain reaction, then we have to insert these control rods. Boron and cadmium can be used as control rods. Okay, these control rods, this is a, for example, boron or the cadmium, we can use it here as control rods, and these control rods are inserted into that core. At the moment the released neutrons completely absorbed, at the moment the chain reaction will be stopped, right? And the next, in this reaction, what happens? Large amount of energy releases. That released energy is passes through this coolant, the hot water. Okay, the passes through the coolant. Coolant is the used as water at high pressure. Then when the coolant heat, released heat passes like this, when it passes through this, what happens? And here we will use some water at high pressure, and that water gains the heat energy and it convert into steam. That steam will be comes outward, and when the steam will be comes out, the steam will be condensed and converted into water again, the cool water that is again is entered to this. And this in this what happening, continuously the heat absorption takes place in this. Okay, this is the coolant. Released heat will be passes like this. In this the water will be there. Okay, that water can absorb the heat that is generated in the core, that will be passes like this, that is absorbed by the water and that convert into steam. The steam will be comes outward with high pressure, that is used to rotate the turbines. The turbines are connected to the turbines connected, turbines will be rotates with the help of the steam. Okay, then after that, that rotating mechanical energy converted into electrical energy by using AC generator. Okay, right. This is about working. I have understood, students. Is it clear? Any doubt? Write in the chat box. Working. Write in the chat box the working. Okay, we will go. We will write the work. I will write the working now. Very simple working. I think you understood. Just it was very simple. Okay. Okay. We will start the working. And Right. Okay, now it is settled. I'm going to write the working, right? And the theory is taking much time to write. Okay, right. Now, firstly, what we have to do? A slow neutron. A slow neutron is allowed to bombard on the uranium that will undergoes the fission and energy releases. I will write the working. A slow neutron. A slow neutron. A slow neutron allowed to a slow neutron is allowed to bombard on 92U235. Okay, slow neutron is bombarded to uranium. This uranium is the fuel. Then what happens? It undergoes it undergoes fission. Fission means what? Splitting. After that, what happens? When it undergoes the fission, energy releases, right? It undergoes fission with the release of 2.5 neutrons. 2.5 neutrons, how it will be releases? In average, that one, once 2, once 3. Okay. In average, along with along with 200 mega electron volts energy. Mega electron volts energy. These neutrons, these neutrons slow down. Okay, the released neutrons, 3 neutrons are released at here, but they are the fast moving neutrons. These neutrons are slow down by using what? Moderators, right? And controlled means absorbed, controlled by using control rods. When you want to stop, then you can stop by using control rods. The energy released, the energy released, this energy releases, right? The energy released in the form of heat, in the form of heat, used to boil water. Okay, the water can absorb the heat released in the reaction. Okay, used to boil water to produce steam. The steam, what this steam will do? The steam rotates the turbines, rotates the turbines. Steam rotates the turbines, and here this is connected to AC generator for the shaft. Then what that AC generator will do? AC generator converts AC generator converts turbine mechanical energy turbine mechanical energy into electrical energy, into electrical energy. Okay, like this, nuclear reactor can be used to convert the nuclear energy into electrical energy. This is about working. And now, what are the uses? Is there any other uses are there for the with the nuclear reactor that we are going to discuss now? You listen very carefully. You are boring with this topic, na? Because the theory topic, writing, and writing, it is not completing, right? And the next applications of nuclear reactor, where we will use this nuclear reactor. Applications of nuclear reactor, where you will use this nuclear reactor. Okay, in our India also we have the nuclear reactors, right? And this nuclear reactor, the first use is that to generate electricity, we are using this one, right? To convert the nuclear energy into electrical energy. To generate electricity, we will use this one. And the next one is to produce to produce nuclear fuel. Okay, to produce nuclear fuel like plutonium 239. This can be generated by using a nuclear reactor. The third one is that this nuclear reactor also used to produce. Okay, these are used to nuclear reactor used to produce radioactive material. They are used to produce the radioactive radioactive material. Radioactive material. These are used to produce radioactive material, which are used in medicine. They are used in medicine and industry and research. Okay, these are the applications of nuclear reactor. And the next one is the power of the reactor. Okay, more 10 minutes I will take the class. Right, the power of nuclear reactor. How we can write the power? Power of nuclear reactor. Power of nuclear reactor. How to find out the power? Power means energy by time, right? Power is the energy by time. Power is equal to we have energy by time. This is the formula. I want the nuclear reactor power. That means now, for example, uh, E is the energy released per fission. E is the energy released per fission. For example, n fissions. N is the number of fissions in time t. Number of energy released per fission. Energy released per fission means in one fission how much energy releases. That is E. Number of fissions in time t is n. N is the number of fissions. Okay, you see here this power formula we write like this. Time is t. Okay, in one fission how much energy releases? One fission means one splitting of uranium. That is E energy released. But n fissions, Ne energy released. That means the power is equal to Ne by T. This is the formula for the power of nuclear reactor. Power of nuclear reactor is the Ne by T. Okay, right. For example, this is the total power of the nuclear reactor. In that, some note I will give. I will close within 5 minutes. If X% of energy released in fission convert into convert into X% of energy released in fission converted into electrical energy, then what happens to the output power? I want the output power. Output power is equal, we write as output power I want. Okay. Then output power is equal P out is equal to only we write here X% of total power, right? Only X% converted into electrical energy. Then electrical energy output power is how much? Released energy not totally converted into electrical energy. Electrical power I want, that is output power equal to X% of total power. Total power. What is X%? X by 100. What is the total power? Previous equation. That is the NE by T. Right? This is the formula. Okay, we will discuss one problem, and that is a previous CBSE question, and then after that I will close today. The problem is that a nuclear power generator, the question, very important problem. Okay, and that is a nuclear reactor, a nuclear power reactor, a nuclear power reactor generates electric power of 100 megawatt. How many number of fissions occur per second if nuclear fuel used in nuclear reactor is uranium? This is our question. Okay, I will wait for the few minutes and you write in the chat box answer. Try for it. What they are asking and what we have to find out in this. Can you write a nuclear power reactor? Okay, try for the solution. Do it fast. Write in the chat box. What they gave in the question first you have to write. Right now, what they gave in the question? A nuclear power reactor generates electric power of 100 megawatts. Means power they gave was 100 megawatts. Right? Power P is equal to 100 megawatts. This you can convert into watts also. 100 into mega means 10 power 6 watt. Okay. This you will get as 10 to the power of 8 watt. What they are asking here, how many fissions occurs per second? Means number of fissions per second we have to find out. And the sample used in the is uranium. Uranium means what? Uranium, how much energy releases in fission, in each fission? You know, na, that one? Energy released in one fission, you know. Energy released per fission. Per fission means one fission. Energy released per fission in the uranium. Energy released per fission is what? In one splitting, the energy released is 200 mega electron volts. We discussed previously. This you can convert into joules. 200 into mega means 10 power 6. Electron means electron charge we have to write. and joule. This is converted into joules. You simplify it. 10 to the power of 2, 10 to the power of 6, 10 to the power of 8, 10 to the power of minus 19, 10 to the power of minus 11. Right? We are getting the 3.2 into 10 to the power of minus 11 joules. You got energy released in the per fission. Then what is our question? Question is the number of fissions per second is what? Number of fissions per second we have to find out. How many fissions takes place in 1 second? That is nothing but n by t we have to find out. Number of fissions per second is nothing but n by t. What is the formula for the power? Power is equal to, we know, energy by time. Energy in one fission is E. N fissions energy is N E by T. Energy N fissions N E. Time is T. Power equal to energy by time. From this, if you want to write N by T, what you will get? P by E we will get. Right now? What is the P? P is what? 10 to the power of. Can you tell what is the P? P? 100 into 10 to the power of 6. 10 to the power of 8. By E is what? 3.2 into 10 to the power of minus 11. If you simplify this, that 11 goes to numerator, then 1 by 3.2 into 10 to the power of 8 plus 11, 19 we will get. And this we write as 10 by 32 into 10 to the power of 19 we will get. This we will also convert like this: 100 by 32 into 10 to the power of 18 we will get. To simplify this, we will get 3.125 into 10 to the power of 18 fissions per second. This many fissions will take place. 3.125 into 10 to the power of 18 fissions per second. Have you understood, students? Is it clear? Actually, so many topics I want to tell, but due to the writing, actually theoretical topic, if it is derivation, then it will complete fastly. But due to the theoretical topic, whatever that I am expecting, that is not completing, right? Because of writing. And the next time, what I will do, next class is very easy. It is some reactions will be there, and more half an hour required to complete this chapter. Okay, and I will complete this chapter in the next class. Okay, and I think somewhat it is boring, but due to the writing. Okay, thank you, Twinkle and Priya Mato. You understood means. Okay, thank you to all, and I am closing. And today evening also I want to take the class, and then we will close this chapter. Okay, thank you to all. I am closing the lecture.